Welcome to the Weekly Squeak, your weekly geeky squeak with me, as always, Chris Chinchilla. I hope everybody is okay out there. I took a little bit of a break last week. I just felt like it. No particular reason. I am also sorting out some of my audio issues, thinking that my sound is coming through to you a lot clearer, hopefully. We shall see. Should see in the comments, I guess, on anyone, mostly on YouTube, who comments on that sort of thing. You podcast listeners are lovely. But this week I have an interview with Neela Jacque, I should say, probably, of Isovalent, an eBPF powered observability cloud native tool. And if any of that meant anything to you, you'll be very excited. If that didn't mean very much to you, then you should also be excited. But you might need to do a little bit of background reading first, possibly. Not sure. Anyway, before that, here are my links of the week. So first, this is a post from Liam Tung, another regular here, on ZDNet about Visual Studio Code and how much it's paying off. 14 million users, and I am a user of it as well. It's claimed, according to statistics, that there are about 24 million developers, and if 14 million of them are using Visual Studio Code, that is quite incredible, actually. It's almost slightly concerning in some ways, maybe, but it's still good. I like it said down here, even some journalists are using VS Code to write stories. Well, I use it to write all sorts of things, actually, and I've recommended it to many other people. Has a lot of language support, etc., etc. That's basically the story. Not much to it apart from just being completely amazed by how many people are using it and how well it's doing. And Microsoft also uses this opportunity to talk a little bit about inner sourcing. So basically using the open source methodologies for internal projects, not just coding projects, but all sorts of things. And they pinpoint specifically the live share feature, which came out 3 and a bit years ago. And that is a feature they actually used in-house before releasing that kind of thing. And I have used it a little bit. Actually, I've known a few people looking into pair programming, using that and other tools like it. It's obviously become something far more common to need over the past few months. But yeah, if you're a VS Code user, then always like to hear from you. I have also maintained a couple of extensions of VS Code. If you're not, what do you use instead? I know there are other options still out there. Any of the less obvious ones would be nice to know. And next, a few articles around the whole WhatsApp debacle that they kind of brought upon themselves. First, this is from Casey Newton over on The Verge, the battle inside Signal. And this is something I have been mentioning to a few people who have switched to Signal recently. I'm not necessarily dismissing Signal as a worthwhile and valid option for switching to, but I think my main concern around Signal is they don't have much of a business model beyond donations. And that is concerning because if it's optional for people to donate to a project to keep it going, that doesn't tend to happen at scale, which concerns me. So whether Signal, the technology, the company, the foundation will be able to sustain themselves at such interest levels that they've been experiencing with that kind of revenue model concerns me whether they'll be able to. It also concerns me because if they're not, what will they do instead? And I think this is always something that bothers me with products, when you're not completely sure how they make money. There's always a slight concern about how they could, how they do, how they will. And this is a really interesting article talking about some of the background behind Signal, and also, what they've been going through the past couple of months, really, and how they've been adapting to it and figuring out what they are going to do next. So if you'd like to know a bit more about that and to sort of understand where they may be going and how they might be coping and figuring out that strategy, then this starts to touch on some of that process they're currently going through. Somewhat related, an article from Matt Burgess over on Wired, talking about one of the other beneficiaries of this recent switch, that being Telegram. And Telegram also, well, no, I'm not saying also, I don't want to put Telegram and Signal in the same light. Many people have had issues with Telegram for some time. Signal doesn't necessarily have any detractors, but that actually its encryption is not necessarily as good as you may think, amongst some of its other problems. Disclaimer, I mean, I use pretty much every messenger just because I have to if I want to talk to certain people. But it's an interesting dig into some aspects you may want to be aware of before you suddenly move everything to it. And finally, this is another piece from Wired, from Margaret Taylor. Is this the end of WeWork? Actually, this is an interesting perspective on co-working spaces generally, and something I've been thinking about myself, in that in the short term, co-working spaces are having a very bad time. People are not really going to them. But in the long run, they will actually be in a good position, because people will still want some sort of office space, but maybe not the big kind of permanent offices they had in the past. But they may want hot desks for people in certain cities, rented rooms at a smaller scale, sort of for floating meetings and things like that. So actually, in the long run, it could be very good times coming up for co-working, but they just have to hold on in the meantime. And this article goes a bit more down the path of WeWork specifically, and their finances and their constant finance issues. But I guess what them and a lot of the co-working ecosystem generally is sort of holding out for and hoping for, and just trying to keep going in the meantime. That was my links for the week, and now here is my interview with Neela Jacque of Isovalent. Enjoy.
So my name is Neela Jacque. I am the VP of Marketing, Business, and a few other things at Isovalent. Isovalent is a startup focused on revolutionizing marketing. And maybe I should take a quick step back and tell you a little bit about how I got to Isovalent. I came out to Silicon Valley in 2006 because I heard about a company that was looking to deliver infrastructure fundamentally differently. And as someone who's loved technology for many, many years, the idea that changing the underlying substrate of infrastructure could impact everything above was just very attractive to me. And so that company was VMware. And the hypothesis was that delivering servers as virtual machines could fundamentally change everything. And it did. However, what I hadn't sort of quite understood by, let's call it 2013, what I hadn't realized was that compute was important, but compute was only one element. And that, in fact, one of the things holding us back, holding our industry back, was the state of networking. And so I started looking at how do you make networking more intelligent? And at the time, I found an open source project called the Open Daylight Project that was looking to bring about something called software-defined networking. And again, this idea was, hey, look, we've built this very brittle, very fixed, hard to change network out there. How could we bring intelligence into that network? And spent a number of years doing that. I mean, the kind of good and bad news is I think it was the right idea. The problem was that we were trying to change the network on an infrastructure which had gotten virtualized, but wasn't it fundamentally different? When we went from a physical machine to a virtual machine, and I think this is the brilliance of VMware, was that what we tried to do was change as little as possible. So everything you did in the physical world, you could now do in the virtual world, which was fantastic for bringing about virtualization. But there was a problem, which is the second order benefits that we're all hoping to get from a virtual infrastructure. Well, if you're just doing what you were doing before in a better way, you're still doing everything you were doing before. And so trying to change the network and revolutionize the network was hard when the underlying infrastructure substrate and the way the apps were written was the same. And so fast forward a few years and something major has changed. When we moved to containers, rather than do what we did with VMs to say, oh, we'll just take VMs and turn them into lightweight containers, we said, well, this actually allows us to build apps differently. This allows us to build apps in a microservices way. So rather than build some big monolithic app, what we could say is, you know what, I'm going to build a shopping cart, and I'm going to build have the ability to spin up lots and lots of instances of that shopping cart, so that if a million people all need to use the shopping cart at the same time, well, I can just spin up more of those instances. So when we move to a microservices architecture, we're now in a place where, I've got a chance to build a new kind of network to be able to manage that. And that's really what Isovalent's been about. It's about being able to bring intelligence into the network, to be able to program the network, but specifically built for microservices architectures. And so it's really the confluence, I think, of a few different things coming along. One is that ability, that idea, that need to program the network that came from its roots in SDN. Mm-hmm. And in fact, our founders were earliest people bringing SDN to life. Sorry, just to finish the build. The second one is people moving to microservices architecture. And then the third one's going to be a technology we'll talk about called eBPF.
Now that's where I wanted to come to, because I think I've had a couple of interviews on the show in the past about software-defined networks in a few different companies. But yes, you have this eBPF, and I must admit, I looked around the Cilium site, I looked around eBPF.io, and I still, what does it stand for?
Well, let's strip the E away for a second. The BPF stands for Berkeley Packet Filter.
Oh, okay, fair enough. Right.
So what's a packet filter? A packet filter is something that looks at a packet and says, okay, what do I do with that packet, right? Do I forward it along or do I stop it? That's in a nutshell what BPF is. eBPF is taking this BPF technology and bringing it into the modern age. It's extended BPF. And this is probably the most exciting, biggest change that has happened to the Linux kernel in the last 20 years. It's been called superpowers for Linux. At a very simplistic level, eBPF is a way to safely embed a program in the Linux kernel. So think about it, literally, you're a developer, we write programs and they all sit in user space. But until very recently, trying to change the Linux kernel was incredibly dangerous. You could write a program to change the behavior of the Linux kernel. It was called a kernel module, but you are basically bastardizing the Linux kernel. If you do it right, you're all good. If you do it wrong, you can break stuff really badly. But then every time you go do that, now I've got to do it on every single instance of Linux that I'm running everywhere. And what eBPF does is it takes the best part of that without any of the downsides. And so what eBPF does is allow somebody to write in code a program that then goes through a series of verification process to make sure that it will not harm the Linux kernel. It then gets compiled just in time, and it sits down at the kernel. So that sorry, I had a little glitch on the phone. So it has access to all the data the kernel has. It also has the ability to tell the kernel to do anything with, say, a network packet that the kernel has access to. The kernel is the first thing, right? And an application says, I want to send some data somewhere. What does it do? Well, it says to the kernel, hey, please send this packet over there. So the kernel sees it. It knows who asked it. It knows information that's around it. It knows contextual information. It knows where you want to send it. And so by programming the kernel, we can make far more intelligent decisions there.
So whilst I guess this sounds interesting for kind of normal Linux users, I'm guessing that's not really the use case. And where does this fit into containers then? I have a sort of a hunch, but yeah, where does this fit in with containers?
Sure. So, I mean, let's start. I think there's two parts to your question. The first part is, in general, does this have to be long-term container specific? Yeah. And the answer is no. Long-term, I mean, I believe lots of people believe, if you go out there and read about what people are saying, eBPF has the potential of fundamentally changing networking, observability, security as we know it, right? If we think about, let's take something as simple as a firewall. What is a firewall? It's a server that's really, really good at dealing with IP tables, right? We've given a list. In the early days, we gave it a list of blacklists and a list of whitelists, and then we've added more and more intelligence on it. But it's a separate box that does nothing but think about what to let through. What is a router? It is a server whose sole purpose is to figure out where and how to forward packets out there. By having access to eBPF, we now have the ability to do pretty much everything that a firewall or a load balancer or a router does, but now have it done at the kernel level, which is far more efficient, far more powerful, more visibility. So that's the overall long-term vision. Short-term, though, where do we see this really going and being implemented? Where is there a problem and where is there an opportunity? And that is in the world of containers, and specifically the world of Kubernetes. Because what happens in the old world is a server is an IP. How do I understand what it's trying to say? Well, the first thing I look at is the ports that it's trying to use. In the new world, I have an IP address. That IP address may stand for many different containers that are in there. It may be transient and last 10 seconds, or it may last hours. And so an IP address and a port is just no longer that useful. And so by being able to embed into the Linux kernel this capability via eBPF, which is what Cilium is, we now have the ability to create networking, security, observability for the Kubernetes world, for the container world, that solves a whole set of immediate problems and is really next generation in its potential.
So does this effectively mean that you can replace a lot of those network components with containers effectively? Is that
So let's first start. Our applications are being built on containers now, right? If you're building a modern application, let's just say that you're building a new insurance product, right? And in that insurance product, you need to gather a whole bunch of information. You need to eventually bind to someone, potentially take a credit card, right? There are many different elements. These days, you don't build that application the way you did 20 years ago. You're building it as a series of microservices that are all interconnected. Let's go even a little bit further. You want that application to be really fast, because if it's slowed down, somebody may say, you know what, I'm going to do it tomorrow, and then go to your competition. And so elements of that app are going to be sitting at the edge really close to some of your users, right? It's not one big monolithic app. It's a whole bunch of little ones. So what Cilium does, leveraging eBPF, is help you to say, okay, let me connect those elements together. Let me monitor those elements. I need a service, let's call it my background check service, to be able to talk to my credit card service, because I've got to put in my credit card to pay for the background check, as an example. Those two have to talk to each other and nothing else, because there's a lot of really critical information there. So I've got to set up network policies between them. Hey, I may get a flood of people, so I may need a whole bunch of these, say, credit card authoring. So I need to load balance across all of that. So I've got to have intelligence on how I load balance across that environment. Hey, some of my users had an issue and suddenly it timed out. Why? Is it the network? Did I make a change? Did I make an update? I need to be able to quickly audit. Is it a hack? If someone got into this, I want to be able, we can't prevent every hack, but what we can do is we can prevent its spread. And so as we're building these microservices environments, firewalling is no longer primarily what we call north-south between a user coming in and the underlying infrastructure. We've now broken that infrastructure in tons of little pieces. And so when someone gets into one piece, often they're not going to get into, say, your credit card authorization system. That's really secure. They'll get into something else, some minor piece of data, and then they're going to try and migrate laterally in your environment. So firewalling now has to be what we call east-west, between components. Load balancing used to be north-south. It's now east-west. So you see how we've created a new world that is so much more powerful from an application standpoint, from an infrastructure standpoint, which is how companies like Zoom can have expanded so fast during COVID, how e-commerce companies have been able to expand so fast, like Shopify. But it means that it creates a whole set of new requirements for the underlying infrastructure.
So before we dig into Cilium and also then Isovalent, I just want to clarify, we mentioned software-defined networks. So not necessarily technically speaking, but I guess from an implementation perspective, what's the difference between eBPF and SDN And is there a case where someone might want to use one over the other, or should everyone just switch?
Yeah, no, that's a great question. So as I said, our two co-founders, earliest folks working on key SDN technologies. The underlying goal of SDN was to have a more programmable network, right? To bring intelligence into the network. And so SDN was looking at the infrastructure that was in place at the time, and specifically looking at how do I bring intelligence to that. And so primarily we had a world that was dominated by physical elements. And so there was two real elements to the SDN side. One piece was to virtualize things, to create vSwitches, to create switches that were virtual. And so in those early days, we created Open vSwitch. Was in fact a project that was created at Nicira, where one of our co-founders was from. And he created OVS to start creating a software construct that could now be controlled.
Yeah.
The second piece of it that was out there was how do I add intelligence to the existing physical infrastructure? And so you probably heard a lot about OpenFlow, which is a new protocol to be able to pass management information and to say to a switch, hey, here's what I need you to do. The difference that we've got today is that we have, as I was saying, fundamentally changed the underlying infrastructure that we can control. And so if the world of SDN still assumed primarily an old world infrastructure that was hardware defined, that was ruled by IPs, SDN, by the way, I should say before we move on, SDN is still actually being used tremendously. It's just become a feature of the network. It's why you don't hear much about it anymore.
I think, to be perfectly honest with you, the only reason I bring it up is because of some of the events I've been to the past few years. I've only just heard people talking about it. So I guess I thought it was newer.
Well, no. And in fact, if you look at Gartner, it's down there at that trough of whatever it is trough. Now. Well, I mean, let me give an example. If you look at AT&T, AT&T is a big wireless carrier. Like every wireless carrier, they're using SDN technology all over the place. So is Google. But it's just become a feature of how we manage legacy networks. VMware, many large VMware environments right now are running NSX. It's a multi-billion-dollar business. A lot of that technology from OVS that came from the Nicira acquisition is embedded. So, SDN, I look at it as it was a really important evolutionary path. It had exactly the right goals. It had a set of means that mapped to the infrastructure that was dominant at the time. It's still being used. There's still, as I said, a multi-billion-dollar business of VMware out there. But if we look at where we are, I think the smartest minds in the world have moved on now and realized, I was just talking to a big bank, and they explained to me, they said, every 10 years we have a strategic infrastructure. 20 years ago, it was moving from the mainframe over to PCs, right? And we had all of these PC-based servers, whether they were Intel-based servers. This was a big shift for us. And then they talked about how virtualization was the next big platform shift. And they virtualized everything, sometimes on VMware, sometimes on OpenStack. And now it's all about Kubernetes. And I was just looking at some data around on Kubernetes that you've got almost everybody is doing something on Kubernetes. But only 6% of companies out there have a substantial amount of production workloads that are sitting in their Kubernetes environment.
And it feels like it's been with us for a long time, but it actually hasn't. I think that's probably what stops a lot of them, I suppose.
I think the technology has been around for a long time.
Yeah. With the name.
Here's an analogy I like to use is let's talk about video conferencing. How long has video conferencing been around? Right? Skype was around 15, 20 years ago.
And things before that,
but it's only recently that we spend the majority of our lives on Zoom or
thanks to WebRTC, which is sort of effectively the Kubernetes of video conferencing.
It took COVID to accelerate it.
Yes and no.
There was that, But there was that point in which it just worked. Right. Yeah. And I think that changed everything. Before, it was a punchline, and now, for the most part, it just works.
It just worked until browsers suddenly added permissions to everything, and then it stopped working for a lot of people. But that's for good reasons.
Right.
Anyway, before we digress, I just like to, I kind of like to start at the open source layer and build up. I'd actually just like, because you have kind of two open source projects. The eBPF, is that an actual technical project, or is it a standard and a steering committee? What is it in particular? eBPF.io, I'm kind of referring to here, I suppose.
Yeah. No, well, eBPF is the project. eBPF.io is a website that we and others in the community maintain around it. So eBPF is a project. It's a subsidiary project of the Linux project. Since inherently this is part of the Linux kernel. So at some point, believe it or not, Linus Torvalds presses +1 on every change that is made to eBPF. I mean, not directly, obviously. There's a Git chain below that. eBPF is a project. It has two major co-maintainers. It is within the networking subsystem part of the Linux kernel. And the two maintainers, one of them works for Isovalent, the other works for Facebook. And if you look at the people maintaining and investing in it, the vast majority right now are at Facebook and Isovalent. But plenty of people in the community care and contribute on it. Google has talked a lot about their view of it, and pretty much, I mean, if you look at it in the industry right now, everybody is definitely looking to leverage it, and plenty of people want and will be, I think, continuing to contribute to it. The problem, of course, is like everything in the Linux kernel, there aren't a lot of people in the world with the expertise to be able to contribute to it.
I think I just clicked on a GitHub repository thinking, what? You've written it in Node, and realized that was the website. That was the website repo, not the eBPF repo. And then,
And I should say eBPF, and you see this when you're in eBPF.io, and I think it is a great resource. One of the interesting things that you see is eBPF, as I said, is a way to embed programs.
And there's a couple of options.
The question is, what do I want that program to do? And probably one of the simplest things is things like tracing. There's a lot of great use cases around around speeding up applications, understanding how fast they're going, making them faster. Brendan Gregg at Netflix is someone who's really invested a lot in developing that part of it. He's written books on it. In itself, it's a huge stream. It's not really what we're focused on primarily at Isovalent. But this is where I want to point out, if you look at eBPF, there are really three ways that you can engage with it. If you're a tinkerer, you can try and write your own eBPF programs. And writing a simple hello world eBPF program is hard, but not that hard. Writing a complex one that does a lot of stuff gets a little bit harder. So then the second thing I would say is you can go down the whole tracing part. And, I would suggest just go leverage something that Brendan, go read Brendan's book, and you'll find a whole bunch of tools that other people have created and written about. And there's a whole world of folks for whom that's great. And again, you can supplement that by writing your own. And then the third one really is eBPF for networking, observability, and security.
We're coming up to that point. So let's get on to Cilium, which is, I now realize, an eBPF implementation. There are others available.
That's right.
So let's get to Cilium now. So yes, eBPF-based networking, observability, and security, which that's a lot of things in one.
But here's, it is and it isn't. Which is, let's start about what is networking. Let's ignore the other two for a second. What is networking? It's about connecting things together. Well, but is it really? It's about connecting things together, but you don't want to connect everything. You want to connect the things together that should be connected to each other. Oh, okay, so you want to have some connections not allowed. Absolutely. Great. Well, what happens if I don't allow the right one? What happens if I allow the wrong ones or don't allow the ones that should be going? Well, then my application breaks. So you're saying I not only want to network and connect, but I want to secure by not connecting. Oh, and I need to be able to observe the traffic that's going. This is why what is networking, observability, and security? Are those three separate things? No, in the context we're talking about, they're all inherently around the same concept, which is what I'm trying to do is let the traffic go where it should go in a way that makes sense at a highest level, right? And not the traffic that isn't, and be able to see and understand what's going on in my environment. That's the problem set that Isovalent is focused on. And specifically, we're looking at the world of microservices, of containers, of Kubernetes, because that's the world where the laws of physics have fundamentally changed versus the old world that we had.
Hmm. And was this created purely by Isovalent, now Isovalent employees, or does it still have a broader community as well, like eBPF itself?
So both. So it's interesting. Cilium was created prior to the formation of Isovalent.
It's a pretty normal process. Yep.
Yeah. Thomas Graf was
Yeah.
the main father of Cilium, but certainly he had plenty of collaborators out there. Today, if we look at, Cilium is an open community. It has contributors from plenty of organizations, Google being an obvious one. That said, like many open source project, we are very much, if you think about it as the sponsors of the project, a large percentage of the code is written and maintained and supported by Isovalent employees.
Yeah.
However, because we have such a strong background in open source, like companies like I'd say HashiCorp, we have a really strong commitment to open source. And, there are people for whom open source is kind of a marketing thing. They're doing open source because it lets people know who they are, but their goal is as quickly as possible to flip you and bait and switch you into the proprietary stuff. We, I think, take a very different view. We build Cilium in such a way that we want and expect the majority of users to end up using the open source software code in production in their environment. And we recognize that some portion of people will never, ever pay us a dime, and that's okay. On the other hand, we also recognize that, look, this stuff is pretty critical to your environment. And as we hear all the time, people want help, people want support, people want functionality beyond. They want the ability to have role-based access control. And there are all these needs from the security team. So there's a lot of value that you can provide on top of this free and open source core that we have.
And actually, you have a pretty good contributor list once I look at it. There's obviously a handful right at the top, but then the list goes down quite some way with still people with reasonable quantities of commit. So it's a good, healthy open source project. I will say that.
Absolutely. And I mean, look, if you look at our GitHub stars and GitHub star counts, I think this is, testament to Thomas Graf is someone who is very well known in this industry. I think he's just really well regarded. And I think this is one of the things you have to see in open source is someone looks at you and says, hey, I'm committed to open source. I've put this out. Do you believe them? You have to look at their background, their history. Yeah. How have they acted? It's those little decisions, and the community, I think, votes with its feet. And what we see with Isovalent and Cilium, it's why I joined the company. I think you've got a company that for years and years and years has demonstrated that commitment to open source in the community.
So let's come up the next level to Isovalent. Firstly, as a product, how old is the company?
Right. The company so Isovalent as a company, as a legal entity, is between 3 and 4 years old.
Okay.
We focus the vast majority of our resources on building Cilium open source for the majority of that time. We just recently, just a couple months back, actually emerged from stealth as a company.
Yep.
We really do two things. The first one, as I said, is going and continuing to create this open source goodness that is Cilium open source. But then the second thing is we built something called Cilium Enterprise. And Cilium Enterprise really has 3 primary components. At the base layer, there is an enterprise hardened distribution of Cilium open source. So you can think of it as RHEL for Linux, Red Hat Enterprise Linux, right? In the sense, you're putting this thing in production at the heart of your biggest networks. You want a release that has been banged on, that has been tested, the way you're not on the bleeding edge, that it's not changing every 5 seconds. That's really the Cilium Enterprise core distribution is what it's all about. And you want that ability to, if there's an issue or you're trying to understand something, You pick up the phone, you send a Slack message, and there's someone immediately there who helped build this thing, who can help you diagnose. So that whole support and subscription is one piece of our business. The other piece is recognizing that complex organizations have needs that go beyond sort of the core platform elements. And that breaks up, as I said, into two pieces. One piece is security, and I'll start that one with telling you a story. We have a customer of ours, and in fact, they just recently gave a talk at the eBPF Summit on this, called Capital One. Yep. And Capital One talked about how critical and strategic this Kubernetes investment is for them. They want to move workloads on there. And what you hear the speaker talk about is how at one point everything was going great. They were ready to do this big migration, and security came in and said, timeout. And they said, no, you can't do it. And they said, well, why not? And they said, well, a lot of our existing tools don't give us the visibility that we need. I can't be sure, you can't be sure that someone can't hack into this environment. And if, for example, there's a call that comes from something in your Kubernetes environment out to a, let's say, a nefarious website, I can't necessarily know what process was that? When did it happen? Why did it happen? All of that information. We hear this across customer after customer after customer. My old tools, which fundamentally assume that I've got a set of physical servers or virtual machines that all have an IP address, don't give me the visibility that I need to be able to certify. So as I said, their security team and many other security teams said, timeout, until you're able to solve this issue, we can't go forward. So one of the things that we have created is the ability to provide that visibility, because thanks to Cilium, thanks to eBPF, because we're able to see what process actually initiated that, right? Regardless of which IP address ended up coming in, our sense of identity actually comes from the process itself, which is identified in Kubernetes and identifies itself to the Linux kernel. And so what Isovalent does is take all of that rich information, figure out which one matters, summarizes some, keeps the rest there, and is able to stream it. Think of it, like oil going through a pipeline. We can take all of that information and provide it into a company's existing security dashboard. So if you're using a SIM system, if you're familiar with Splunk or
right, okay, yeah,
I've got a system already that's going to go ahead and give me an alert if there's an attack in my environment. If someone attacks my Palo Alto firewall, I'm going to get a big red X. But what happens if there's something that goes on in my Kubernetes environment that I have no visibility? I get a big X and it's next to an IP address that's meaningless. Thanks to Isovalent, we're able to take all of that rich information and, hey, I get the red X, I click on the red X, and what comes out there is, here's a process tree. And I can figure out that there's a curl script that ran inside this exact container at 4:32 p.m. last Tuesday, and it made the call. And in fact, that curl script was added Wednesday of last week and doesn't exist in any of the other pods. You see the power of that?
Yeah, just out of interest though, I mean, there are obviously other tools that provide that too. So is this about giving integration into those, or so as far as I can tell, it's about integration and what can people integrate with? Is it just Splunk, the Elastic Stack? Because you've got Splunk, Elastic Stack, etc. on the description.
So, I would actually take some exception to it's about the integration, because so plenty of things can feed data into Splunk, right? Yeah. I mean, Splunk will ingest, they'll tell you, they will ingest any data that is provided to them. And so the traditional way of feeding something like Splunk is to put a box somewhere, physical box, virtual box. In the world of Kubernetes, we call them sidecar proxies. Yep. What's a sidecar proxy, right? It's basically yet another box that's sitting somewhere trying to observe and taking that data and passing it along. What's the problem with the sidecar proxy? It's sitting outside. Think about someone standing outside of your house looking at who's coming in and out of your house. Well, that's great, but they don't get visibility of what's going on inside your house. So the big difference with us, and by the way, this is why if you look at the world of observability, everybody is now talking about eBPF because there's a recognition that it is so game changing. Because eBPF sits down at the kernel level, it naturally sees stuff that nobody else sees. So everyone else is trying to piece all of this together. Oh, I saw a flow. I saw something. Well, how do I understand? Well, let me go quiz this system and that system and put it together and try and correlate, right? Your firewall has no concept of what app is running behind it, right? All it sees is a port, and it's guessing from a port what's going on. But that's about all it can do. If I want to do L7 stuff, I have to add a WAF, right? And F5 puts a WAF. But guess what? 95% of WAFs are put in monitor mode, not in blocking mode, because WAFs aren't actually that smart and that good. And if you put them in blocking mode, your app's going to break. So we watch it and hope and put it in. Why? Because it's sitting outside of the application. And so the next thing you can do is instrument my app. And if I instrument my app sees everything about itself, which is great, but every app gets instrumented differently. So Datadog is a great example. Wonderful and fantastic. And if I can get every app to be instrumented, if I can get every app to be instrumented the same, then maybe I'm there. But of course, the problem is I've got really old apps, and I've got somewhat old apps, and I've got new apps, and I've got the next newer one, and I've got different teams, and they all built it differently. So now what I'm getting is a bunch of different alerts that are, my 10-year-old daughter and my 12-year-old son, when they complain about a problem, they don't complain about it the same way because there are different levels of maturity. Same thing with the different apps in your environment. There are different levels of maturity.
Yeah. And I think some other services in the observability space have tried to get to that low level, but I suppose they can only ever go so far. And with eBPF, it lets you go all the way down.
And this is where, remember I talked about these things are inherently connected, networking, observability, and security. And I'll give another example of this. A network policy. What's a network policy? It's the idea of saying this node, this pod can talk to this other pod. Okay, great. I can, in the old world, we just allowed everything. Well, that's great, right? And we put a big honking firewall in front of it, and then just said everything, right? That's the old moat theory. I put a moat around my castle. And then we said, well, what we really want to get to is zero trust and deny everything. Of course, what happens when you do that? You break all your apps. Nothing works. Nothing works anymore, right? So I want to create policies. What you find is that go in and ask 100 companies, do you think you should have network policies? 100% of them say, yes, we should. Ask them, how many of you have deployed network policies today in your Kubernetes environment? The answer is 5%. Why? Well, number one, Kubernetes out of the box doesn't allow you to do network policies. It's defined as a standard, but it's not implemented in most distributions, in most clouds out of the box. All right, great. So I can go and put in what we call an advanced CNI to do network policies. Then you'll use it, right? Well, no, actually, a lot of people do very limited network policies because their big fear is breaking the network. So it turns out to use network policy, you have to be able to visualize it, right? What is a network policy? It's a YAML file. It is literally a set of code that you're creating. You implement it, and then you sit there and hope. And you hope that you didn't F it up. You could have effed it up by allowing something that shouldn't be allowed or disallowing something that should be allowed. And either of those has consequences. One, probably later, at which point you get fired. The other one, short term, which creates your hair on fire, and that is your app teams. And so you need help. You need visibility. This is part of what Isovalent does. And I'll throw out a little gem, something that's coming soon. You're going to see a cool separate thing coming out of Isovalent, not directly connected to Cilium, not directly connected to eBPF. That's going to be out there to help people specifically with their network policies.
Is because I did see something around training with Hubble. Is that Hubble?
It's not Hubble.
Okay, all right.
Although it leverages elements of Hubble.
Okay.
But it's anyway, I'm just going to say something really, really cool coming in.
Usually one of my last questions, which I was about to ask, is what's next? I guess I was going to caveat that with the announcement, and the product itself is quite new. So there's probably a lot next. But aside from this unnamed feature that's coming soon, what else is on the roadmap for the next 6 months or so?
Sure. So there's one thing we didn't talk about, and then I'll come right back, which is, I talked about the security issue. The third thing in Cilium Enterprise is actually the multi-tenancy challenge. So Kubernetes, you are basically acting like a mini AWS in a sense, service to your entire environment. And so one of the challenges happens is, hey, I've got a team, they're an app team, maybe there are 10 of them. They have infrastructure on your multi-tenant cloud, and they've got to figure out, okay, something went wrong. I've got to apply a network policy. My network policy has to be aligned with my overall corporate network policy. I implemented it, broke something. How do you give them visibility to just their environment and nobody else's environment? How do you get them the tools and visibility to solve their own issues? So that's the third part, as I mentioned, we have the underlying enterprise hardened distribution, we have the security functionality, and we have the app team multi-tenant functionality. So what's coming next? Really, I think a lot more on all three of those. There's a lot of really smart blocking and tackling. One of the we didn't talk much about load balancing. Load balancing, especially east-west load balancing, is really important. Let me just briefly describe an example of a problem that happens with load balancing. I spin up a whole bunch of instances. I've got a lot of people who hit it. Then traffic goes out. Hey, it's 10 o'clock, 11 o'clock, people start going to bed. I don't need as many of those underlying instances, so I want to start shutting them down. Here's the problem, though. I've got an individual who's in the middle of a transaction. If I shut down that server that is actually handling them, I can lose a lot of that history. We've all had that where we're trying to do something and people deal with it with timeouts. But timeouts are horrible things. What I want to be able to do is scale out and then scale back in a way that doesn't actually jeopardize the longevity of the conversations, the institutional memory that exists within that process, if you think about it. And so one of the big things we've been working on, it actually came out of Facebook. It's an algorithm called maglev, cool named algorithm. And maglev is about being much more intelligent in terms of, okay, something comes in, who do I give it to? And how do I then return the information back to maintain that knowledge of the connection throughout the history of it? So I use that as an example. There's a lot more. Once you've made all of this software, once you've made this all programmable, there's a lot of things that you can do and that you should do. One big area, and excuse the headline's going to be buzzy, the detail isn't as much, is this idea of multi-cloud. So you're going down Kubernetes. Great. Do you have one Kubernetes instance? Well, no, I've got my on-prem Kubernetes, and maybe I'm doing something in the cloud somewhere. Okay, well, which cloud? Well, maybe it's just AWS and on-prem. But maybe that other group is also doing something on Azure. Maybe, in fact, actually it is AWS, but you've got 3 different regions in AWS. Maybe you actually have on-prem, but you have some different regions on-prem. And I'll give you 2 perfect examples just to start on sort of the multiple clusters element. We've got a user who's a big gaming company called Wildlife Studios. Why do you think they put their environments all over the world?
They have players all over the world.
They do. Latency, right? From a latency standpoint, you got to have all these different clusters, yet at some level, your app, in this case, your game, has to be logically centralized. So how do I have a logically centralized game that is being delivered, or elements of it are being delivered close to my users? Oh, and by the way, one region may go down. I still want to serve those players. I might serve a player in Argentina initially from my data center in Brazil. But if that gets overloaded, rather than just continue to add more capacity in Brazil, I can serve it out of Miami because Miami is asleep right now.
Yep.
Right? That, wow, the same time zone, maybe that's the wrong example. Maybe I serve it out of Europe. So already you've got the multi-cluster problem. How do I make multiple clusters still act and feel, given they have completely different namespaces? This is something that Cilium can solve. They've got different addressing information. I can make it all seem seamless like one network with Cilium. The second big element on that is, well, what happens if turns out that in China, I'm using Alibaba for whatever reason, and in Europe, I'm using Azure. And then in the US, I've got my on-prem. I may want an application to be able to run across all 3 of those environments. And I want to think about, how do I maintain some level of network coherence across this? I'm not saying, to be clear, I'm going to build a big multi-cloud dashboard that tells you the cost of an instance across all 6 of them. No, I'm just talking basic network connectivity.
Yeah, you don't care. Yeah, it starts to fill in that gap of, Kubernetes was always supposed to be that abstraction on top of whatever, but where it was hosted was still specific. So, so it starts to bring that abstraction to everything. Yeah.
So multi-cloud networking, observability, and security specifically, not that whole big shebang, but specific to that, that is a real problem. That is a solvable problem. That's something that we're tackling in Cilium. So that would be one big one. A second big one, I would say, and this comes up, a number of our users, I mentioned Capital One's a user of ours, are highly regulated industries. Specifically, we've got quite a lot of banks and insurance companies using us. And one of the challenges that they have is, as I described, is they're never going to have an infrastructure that looks like, say, Datadog's, which is another user of ours, right? Datadog's infrastructure is less than 10 years old, the vast majority. It's been built for the modern era. Your average bank has infrastructure going back to the 1960s. It's a little bit like the Department of Defense, if you think about it, right? And everything in between. So what happens, you start building this new great capability in the brand new thing. And then you start to think about, wait a second, I wish I had that in my old world. Or I actually have an app, and this is very, very common, where my database, my Oracle database, is still physical.
Yeah.
And so how do I think about creating networking, observability, and security for an application when not all of it, when it stretches between the old world and the new world? And so being able to take Cilium, this gets right back to where we started. Is eBPF only about the new world of Kubernetes and containers? No. It can be used across, and it will be used across, but it's certainly getting pulled from the new world.
Yeah. There's a lot we spoke about there. I think that's a good point to wrap up. So I tend to have a fairly developer-focused audience. Obviously, Cilium is something that people can try to their heart's desires. It's an open source project.
That's right.
Isovalent looks like mostly a contact us type product right now, which is not uncommon. But for Cilium,
our website isn't quite like, say, Cisco's website with the.
No, I mean in terms of there's no self-serve option, yeah, but that takes time to get going.
Yes, of course.
It takes time to set up that kind of thing. It's quite difficult to enable people just to spin up kind of trial environments for these sorts of things as they wish. It takes a little bit of time and development work, but maybe that's coming down the future. But in the meantime, of course, you can try Cilium and see where you might need those other needs and then get in touch.
Yeah, I mean, look, I would say the vast majority, our goal as a company is the vast majority of the value is in open source. And I actually don't think this is a major bug. I think if someone is interested, if they're at the point in Kubernetes where they need an advanced CNI, a container network interface, to do many of the things that we talked about, they should implement Cilium. They can do it really easily in 5 minutes with just a small instance of Kubernetes. They can put it into production.
Some Minikube test options as well. I have another stream. I have another stream that I do that I like to put alongside it, where I actually put my hands on some of the products of the people I speak to and see what the onboarding experience is like. So I'll add Cilium to the list.
Installing Cilium and Minikube, it is literally a single sentence command. So you can go in and play with Cilium with one command. We've got a full tutorial that people can go through. And our experience is you can do a lot with the open source side. You're probably not going to start facing the kinds of issues that would require
certainly not on Minikube anyway.
No. Even in production, it may take you a few months of open source usage before you find yourself needing, think HashiCorp. HashiCorp's a perfect example.
Yeah. But there's many in this space, and it's a time-honored playbook and one that I think we understand. It's good, but it's interesting to look down your product page because you can see that there's quite a lot shared between the versions, and it's only when you get a lot further down, so you can go quite far.
That was my interview with Neela Jacque of Isovalent. Hope you found that interesting. They're a very kind of buzzy company and project right now. That whole space is actually. Another disclaimer, I work for something of a, not really a rival, but another project in the same sort of ecosystem that works a different way. But hey, I can still talk to people about what they're up to as well, especially in the open source world. And now just a few small updates from me. So a couple of small things here. Episode 4 of Stories About People, a storytelling podcast I do with Susie Carlick, is up. We have a story about a hurricane and a story about the end of the world. They're not necessarily connected. And then I actually have 2 hands-on sessions. I think my website needed a slight update. A week and a half ago, I did 11T, a static site generator, with a co-host, Rachel Black, who is a DevRel at developer relations at Twilio. And then just this Monday gone, I did Zola, another static site generator written in Rust. And see how they both compare. Jump over to those videos on YouTube, Twitch, wherever you want to watch. And you'll also notice that I've renamed that Dexpose stream to Hands-On, and that will be its new name moving forward. Dexpose is no more, but bits of it are being repurposed into a couple of different places. Watch this space. I'll be back with another solo adventurer this week. I did actually do one last week, but I had some technology meltdowns and ended up not releasing it in the end. We'll be back this week with Alone in the Dark, another Call of Cthulhu solo adventure that will last me a little while, I think. And actually, I will have a few more updates for you very soon. A few new things slotting into place and gradually getting worked out, some of which I've already just alluded to. But as always, you can find much more about me at chrischinchilla.com for all my contact details, my latest articles, and everything else I am getting up to. That has been another Weekly Squeak for this week. I hope you enjoyed the show. And until next time, thank you so much for joining me.